use substitution to find the integral. Oops, I cut off the integral sign here. This is an integral sign of this guy. Okay, so first of all, let's rewrite that. X cubed plus 2x to the power of 1/2 times 3x squared plus 2 dx. Now, is one of these expressions the derivative of the other? Yes, this one is the derivative of this one. Okay, so we're going to let u equal x cubed plus 2x. Now notice then that du dx equals 3x squared plus 2. Okay, so that's good. This is this guy, and this is this guy. All right, so now we have our expression u to the power of 1/2 du dx times dx, which can be simplified u to the power of 1/2 du. We can now integrate that. Add 1, divide by that bigger exponent, and there's our constant of integration. Simplify this, so 2 over 3 u to the power of 3 over 2 plus c. Substitute back in the u value, which was x cubed plus 2x to the power of 3/2 plus c. Very good. Next one, use substitution to find these. So, is one the derivative of the other? Yes. The top one is the derivative of the bottom one. So we could say this is equal to 1 over x cubed plus 2x multiplied by 3x squared plus 2 dx. Let u equal x cubed plus 2x du dx is then 3x squared plus 2. And we've got some things to substitute here, that and this. So we equal 1 over u du dx 1 over u du. And we know that the integral of that is ln absolute value of u plus c. Substitute the u back in, ln absolute value of x cubed plus 2x plus c. Second one. Okay, so this is where we have to start using our imagination. If we can see here, in order to simplify this, we're going to need to let u equal that exponent, 1 minus x squared. And therefore, du dx will be equal to negative 2x. Okay, well, negative 2x doesn't show up in our expression, but x does. So what do we have to do to x to make it look like negative 2x? We have to multiply it by negative 2. Okay, so we need to multiply x by negative 2 to make it negative 2x. All right, but if we multiply by negative 2, we're going to be changing the value of the expression. So in order for that not to happen, we also will multiply by negative 1/2. In order to not change the value of the expression, we will also multiply by negative 1/2. Okay, because negative 1/2 multiplied by negative 2 is just equal to 1. So we're multiplying by the number 1, just that the number 1 looks like negative 1/2 multiplied by negative 2. So let's write down what we have. Integral of negative 1/2 multiplied by negative 2 x e to the power of 1 minus x squared dx. Okay, so here's our negative 2x that we need for this, and here's our u value. We'll substitute. Integral of negative 1/2, this is du dx, e to the power of u dx. Simplifying, I'm going to move that negative 1/2 to the outside of the integral. So e to the u du. We know that e to the power of something, the integral of that is just itself, plus that constant of integration. So here we have it, and substitute back in the u value, and we have our solution. Negative 1/2 e to the power of 1 minus x squared plus c. Okay, pretty amazing, pretty tricky, but pretty amazing that we can do this. And lastly, integrate with respect to x. Here we have cos cubed x sine x. Okay, remember, dx. So remember that this is like saying cos x cubed. That's not proper notation, but maybe that means more to us than cos cubed x. If it does, you can use it in an intermediate step. Let's let u equal cos x. So du dx will be negative sine x. Therefore, this will equal u cubed negative du dx multiplied by negative du dx. So negative u cubed du. You can put the negative out if it makes it easier looking for you. So then negative u 3 plus 1 all over 4 plus c. Extend that page, and we've got negative 1/4 u to the power of 4 plus c. Substitute that u back in. Cos x to the power of 4 plus c. Proper notation is cos 4 to the power of 4x plus c. And the other one, integrate cos x over sine x dx. Okay, we're going to have to let one, you could choose one or the other. Let's see, actually, no, we need to choose, let sine u equal sine x, and that way we'll have 1 over u. Du dx is equal to cos x. So we have, I'm going to separate this, so 1 over sine x multiplied by cos x dx. And 1 over u multiplied by du dx. So 1 over u du, which is 1 u plus c. Substitute back in the u value, which is sine x plus c. Your homework, this is section 18G, remember, so look on the homework document and practice those questions from exercise 18G. Have fun.